All right, now we have another plenary panel, and the speakers are going to be Leslie, John, and Ya Zhu. Leslie's from Harvard Business School. She's going to be speaking about lifting the veil, the benefits of cost transparency. Welcome, Leslie.
Hi, thanks for having me. I study the psychology of privacy. Oh, is this for a tall man? And I'm interested in people's decisions to share or reveal personal information. I'm particularly interested in these decisions given that they've been made dramatically more complex in the new, well, not so new anymore, digital age we live in. So I'm really fascinated by these decisions. The project that I'm going to talk about today is one piece of work in a line of research I've been pursuing in trying to understand how our decisions of what to disclose, they can really have a profound effect on the impressions that we make on other people. And so the one I'm going to talk about today is an example of how when you, and in this case the you as firms, disclose sensitive information that you would think they ordinarily should never disclose, the variable costs to create, say, a t-shirt, it can actually lead to some surprising benefits. Spoiler alert, it can enhance consumers' trust in that firm and increase their purchasing propensity. It's also an example of the use of field and lab experiments in iterative ways. So field experiments, of course, to document effects in the wild, and lab experiments to try to document some of the psychological factors that underlie those effects. Okay, so, but before I get to this particular research, I just wanted to start by elucidating some of the new challenges we face in managing the impressions we make on others with digital media, and whether some of the strategies we pursue to try to address those challenges are effective or ineffective. And that actually provides a segue, our findings from this earlier work provides a segue to motivate the present work. Okay, so one challenge that digital media present is the new permanence of revelation, right? So digital skeletons in our closet can easily come back to haunt us, and the media regularly highlights lots of examples of these, right? So here's just one example. So this woman, shall we say, was venting about her boss on Facebook, posts this message venting about her boss, forgets then, like leaves it up, doesn't delete it, forgets then that her boss is actually a friend. Her boss then, a few days later, sometime later, sees this, proceeds to fire her based on what she posted on Facebook. So the new permanence of our revelations can really come back to haunt us. As the Times has said, the web means the end of forgetting. So how might we try to address this problem? Well, what about temporary sharing, right? So, of course, the spirit of these technologies is to really limit the spread, for example, viral spread of our impulsive disclosures, right? So risque photos can't be shared further if they don't exist anymore. Yep, that's pretty straightforward. But what we wondered is whether there may be an unintended consequence from an impression management perspective of temporary sharing technologies. So they may not be the kind of impression management panacea that we may hope them to be. That's because the impression that your uninhibited, risque selfie disclosure, the impression that that makes on its recipient, that doesn't disappear when the photo disappears. Kind of the reputational effects have enduring consequences. And this, as we show in this paper, is particularly problematic given that temporary sharing actually induces you to take more disclosure risks than you otherwise would have. So we get people to take selfies, and we tell half of people, these are offline field experiments, we tell half of people, your information will be permanently posted on a Facebook group. The other half of people, we say it'll be only temporarily, truthfully, it'll only be temporarily posted up there. We'll remove it after an hour. And then we measure their compliance with this request. We also measure the risqueness of the selfies, and what we find is that people share, they're more likely to comply, and they share more sensitive content. Then what we do is we look at the observer side of the equation. We show people photos that have been shared temporarily or permanently, and photos that are uninhibited or not uninhibited. And what we find, sure enough, is that the uninhibited photos make you come across as having bad judgment, and observers don't correct for the profound situational influence on your behavior. Put simply, just because you share it temporarily doesn't kind of give you a hall pass. It doesn't make the observer say, this person's savvy. They knew that if they're going to send a risque photo, they should send it temporarily. No, you get no benefit from that. A risque selfie is a risque selfie, and it makes you come across as having bad judgment. Okay, so that's one example. Another example that is more closely linked to what I'm going to focus on today is a challenge of the barrage of requests we face for personal information, right? So because it's so much easier for marketers, friends, anyone really, to ask us for information, we may be kind of fed up, and we may want to just opt out of answering and not answer questions. So, Facebook perpetually asks us what's on our mind. We're often asked these questions. And so what if we just are fed up and don't want to answer? From an impression management standpoint, is it a good idea to opt out of answering? Do you make a good impression when you opt out of answering? Well, what we find in this series of studies is that opting out of answering makes you come across as shadier than answering the worst possible answer. So, if you were a participant in one of my experiments, I would ask you to do this. I'm not asking you whether you've actually done this, but what I would ask you to do is I would ask you to imagine that you're looking at someone's survey responses, and imagine they had answered this question in different ways. So what would you think of them if they answered this? Maybe you think they were lying. What would you think of them if they'd answered this? What would you think of them if they answered frequently? Not a good person, probably. But what if there was another answer option? What if they had opted out of answering? Might you view them as shadier than someone who, than someone who admitted to the worst possible answer? And that's in fact what we find. And then we do lots of experiments. You can read the paper if you want to see kind of where we're trying to rule in versus out different explanations, but one kind of salient, maybe reasonable explanation for why you may prefer the person who frequently admits to bad things, the worst possible thing, than someone who simply opts out of answering, is you may kind of make the inference, the person who opted out of answering here, the reason why they opted out of answering was because they couldn't fully express the magnitude of their badness. Like, there wasn't an incessantly category, and if there was only an incessant, then they would, right? So we show that it's not driven by these inferences, and what it is driven by is these global trait inferences of trustworthiness. So this stems from the psychology of self-disclosure. So we know that self-disclosure is a really important part of forging connections with others. And so when someone abstains from that fundamental human activity, we view them with contempt, so much so that we'd rather trust someone, we'd rather date someone, we'd rather hire someone who just comes clean and admits to the worst possible thing relative to someone who opts out of answering. Now, presumably, we would rather choose someone who only lies sometimes or never, but if we had to choose between someone who frequently lies and chooses not to answer, this is the result we find. So what I want to be cognizant of the time here. So I'm going to move on to the main focus, where I want to talk about how revealing information, sensitive information, can actually have a real benefit sometimes. So an implication of this research is sometimes we're overly concerned with revealing information. And in fact, we have studies in this paper showing that when we ask people to say, suppose you were applying for a job that you really wanted, and suppose you've done drugs occasionally. If you were asked on this job application, have you done drugs, and lying is off the table, what would you do? Would you answer it yes, or would you opt out of answering? And we find that the vast majority of people opt out of answering. But then when we ask people to take the other perspective of the prospective hirer would rather choose the person I mean, you'd rather choose someone who truly didn't do it, but if you're choosing between an emitter and someone who opts out of answering, you'd rather hire someone that opts out of answering, and that's because you trust them more. Okay, so let me move on to this project on cost transparency. So as I've motivated it in saying that there may be an upside to revealing sensitive information. This is not to say that we should always tell everyone our deepest and darkest secrets. The disdain for withholders is particularly strong when withholding is very salient. But the flip side is there may be a benefit to disclosing sensitive information. And we know from lots of research in psychology that self-disclosure of sensitive information in particular breeds liking. We also know that trust is correlated with self-disclosure and liking. It underlies this relationship between withholding and dislike, distrust, that is. And then the next question is, so in this particular study, we're looking at when firms disclose sensitive information, might it cause consumers to trust those firms more? And there we draw upon the theory of social response, which posits that when people encounter a stimulus that has human-like qualities to it, we naturally draw on our social behaviors to respond to that stimulus. So there's some interesting work by my colleague Youngmi Moon, which you may have heard of, when she shows that when computers self-disclose, when they say, oh, I wish I could use all my processing power, I'm not being used to my full potential, people like that computer. And so we thought that when a firm self-discloses, people may react in the same way as in human-to-human interactions. Okay, that is, if costs are a form of sensitive disclosure. We ran a bunch of pilot studies asking people, hey, if a firm disclosed its variable cost to create something, how sensitive would that be, versus price, versus who its competitors were, and costs were among the most sensitive forms of piece of information for firms to disclose. Okay, so this is what we posit. I've been just saying it verbally, so I will move on. I'm going to show you. I promise I can say them fairly quickly. They have very simple designs. 2 field studies, and then lab studies that help us to document one of the psychological drivers that underpin this effect. So by cost transparency, I mean this is an infographic of one of our experiments, literally revealing, so this is a t-shirt, and the cotton to make the t-shirt costs $2.75, the cutting 35 cents, the sewing $1.35 per t-shirt, alongside the price. And we measure in the field studies how willing people are, we measure actual purchasing. So in the first study, this was a serendipitous quasi-experiment. So this company was wanting to instate cost transparency on its wallets, $115 wallets. I don't pay that much for wallets. And so they wanted to instate this infographic. Now, of course, this is like a sledgehammer. It has, the top line says the costs, but then there's also this favorable information to the firm on markups and stuff. So this is like a kind of a confounded quasi-field experiment, but I think it's a cool data set, and then I'll show you in a tighter experiment next. So the firm wanted to change, right? So all of a sudden instate cost transparency on the right. They were planning to do this for all colors at the same time. Specifically, they're going to change it all over on January 28th, 2014. But then they had an oops, which was kind of awesome for us. I mean, it would have still been given us some information just looking at the data pre-post. But they said, oh, we actually made a mistake. We only put the infographic on a few of the colors. We didn't put it on all the colors. We're like, yes, amazing. That's even better. So then we got the data and we looked at purchasing. And this is going to be a very bumpy graph, but the next one's smoother. And I can't put the numbers because the firm is understandably sensitive about the absolute numbers. Also, brace yourselves, there will be a mega post-holiday decline. That's going to be the most salient thing we see here. So they were instating cost transparency to maybe help as a buffer against the post-holiday sales decline, because it was right after Christmas. So here's what we see. The treatment with the infographic is in blue, so it kind of looks a little bit like it worked, right, if you just eyeball it. Now, if I smooth it out for you and we just look at pre and post, we do find, in fact, that the infographic buffered the post-holiday sales decline. Now, what we next did was an actual experiment, an actual field experiment, and sometimes the sometimes the easiest field experiments are right under your nose, right? So we talked to Spangler Cafeteria at HBS. We asked if they would run a field experiment for us, and they did, which was awesome. That's just okay. So 2 cells, control, cost transparency, and it was in the we manipulated the label on the chicken noodle soup, and we measured sales of chicken noodle soup. And the control label was like this. So it had already, if you're worried that kind of the previous infographic had like the steps and the costs, this controls for that. It's a tighter manipulation. These are effectively the steps, the ingredients, that's control, and the cost simply puts the costs on each of those steps. This was a pre-registered study over 5 weeks during lunch, and so every day, 11:30 to 12:30, we put one sign up, and then we put the other sign up, and we flip-flopped between days which one came first. And what we found was that cost transparency increased the probability that a given purchase included chicken soup by about 20%, so from 2.3% of purchases to 2.8%. So it worked in this field setting. And then what we did was we did some studies to try to assess whether one of the mechanisms underlying this effect might be enhanced trust. Now, there's also lots of alternative explanations, right? So you might be thinking, well, maybe cost transparency disabuses people of their sometimes false belief that firms are gouging them. And so if you have this belief and you reveal reasonable margins, like reasonable costs, then you may think the price is more fair, and then you may be more likely to buy. And to an extent that might be happening, but we also have shown evidence of this psychological process of enhanced trust. And we show it in particular in contexts in which this price fairness account might predict something else. First of all, one of the things we do is we actually vary the cost. We vary like the gross margins. We vary whether the costs are super low, the costs are super high, keeping price constant. Then we also do it the other way where we keep costs constant and we vary the price. And what we find is that even at like pretty high margins, like about at a 50% margin, we still get that cost transparency increases trust and it increases purchasing. Once you get to like, we've done it with like a 95% margin. I'm from HBS. So it actually doesn't flip, so it doesn't backfire. It doesn't help, but it doesn't backfire, which I thought was very interesting. But to conclude, I'm going to just show you one experiment where we kind of pit, partly as an example of kind of the interplay of lab and field, where we pit this price fairness explanation against cost transparency. So here's what we did. What we did was, this was an online MTurk study. It was a 2x2 factorial design. So people were asked how interested they were in going on this trip that was being sold to DC. And that we either told them the costs of the trip or we didn't. But the other thing we varied was the price relative to their expectations. So we did a bunch of pre-tests to see how much people think this trip costs. And then in the experiment, half of people, we told them the price was higher essentially than what they were likely to expect, and the other half we told them it was lower. So the idea is that if this cost transparency works by disabusing people of this sometimes false belief that firms are gouging them, then it should really only work when people have that belief. When do people have that belief? When the price is super high. When the price is super high, people believe that it's not because the costs are high, it's because firms are gouging them. So cost transparency should work there, but it shouldn't work when the price is surprisingly low because you don't think the firm is gouging you. But by our account that transparency, disclosing sensitive information enhances trust, we should see the effect emerge even at when prices are lower than expectation. And that's what we found. And I'm just going to show you a figure of that, and then I will conclude. So I've just said this verbally. These are just the stimuli. Was this the main? Yes, this is the main result. So you can see here, there's no interaction. Price fairness would predict an interaction. Our account does not predict an interaction. The critical thing here is that on the left side, we still get an effective cost transparency. So that's one piece of evidence in support of this trustworthiness account. In closing, I just wanted to say that there's kind of a dual-edged sword of transparency, whereby firms can benefit from being transparent. This is an example of that. In other research, we have found that when firms, so when they tell you the reason why you're seeing an ad, so what we've been calling ad transparency, if they tell you, you're seeing this information because you clicked a like button for Toyota, we look at how that kind of transparency affects people's interest in purchasing the given thing being advertised. And what we find is that it really can, it can enhance your trust and willingness to purchase if consumers view the use of their information as reasonable and appropriate. So if you are told that your information used to generate the ad was obtained by third-party data sharing, something that people find very off-putting, then transparency backfires. So this implies that firms, they probably want to be transparent if only to get the trustworthy benefits. But sometimes when the truth is icky, they might not want to be substantively transparent enough as to turn people off. And so sometimes as consumers, we get kind of sham versions of transparency. The same dynamic is true with control. We kind of get sham versions of control sometimes. So this presents, I think, a really interesting challenge to try to resolve. With that, thank you.
Thanks very much, Leslie. And so we will have time for questions in 20 minutes after we hear from Yazoo of LinkedIn, who's going to be talking about solving experimental interference, practical solutions. Yeah.
Thank you.
I know everyone is trying to fight the after-lunch drowsiness. We'll see what we can do. What I'm going to be talking about today, obviously, is work done by many people in my group, and actually several of them are here today, Yov, Guillaume, and Jim. So if you have any further questions, definitely look out for them and asking them the tough questions, not me. So I assume that most of you have heard of LinkedIn, but for the purpose of the talk today, you just need to know that LinkedIn is a professional social network that is really aimed to construct the economic graph. We are fairly successful at doing it, and we obviously have a ton of users and traffic, almost 6 million members on LinkedIn, lots of companies and jobs, etc. So at a massive scale. We are also a company that is very much embracing on experimentation. So if you kind of see the growth that we've had on experimentation in the past several years, we literally in the past 5 years have increased our experimentation by 20 times. And now we are actually at running 100 experiments a day. If you think about it, it's a really massive number. That's like one experiment every 5 minutes is launched live on LinkedIn. So a lot of these experiments that we run, even though we are a social network, actually we can do it in a fairly simple way that assuming Sutva and just say each individual response is affected only by their own treatments assignment, but not others. However, this is not true for, again, many experiments we run, and that is going to be primarily what I'm going to be talking about today. So I'm going to categorize interference in these conceptually, two big buckets. One is really a very direct connection from entity to entity. The other one is something that is a bit more indirect connection that is a lot of times due to shared resources and latent variables. I feel like the first one is probably what a lot of people, when they're thinking about interference, they think about it, but just wanted to make sure that we actually consider both cases. So just to give some examples in these two areas, in the first area, that is mostly when people think about social network, they're thinking about the interference happening, right? So A can send a message to B, and B can reply, and they can be in, obviously, treatment and control groups separately. Similarly, with A can post to the feed, and B can comment on A's post, etc. Invitation as well, phone calls, obviously, another one example. So the other really big area is also when A and B, they are connected, not through a direct connection, but because they actually share some, they have shared resources they're competing for. Example would be user A competes with user B over the same apartment that is on Airbnb, right? So Uber is another example that the same riders are trying to compete for the same drivers. Similarly, even if you think about, I have 2 different requests that is routing to the same machine, the same data center, that they could be competing for the same CPU, that you cannot differentiate them. And another one big area is ads campaign, right? So if you have an algorithm that is able to increase ads click, and they are competing for the same budget that the advertiser is setting, so that also introduces interference as well. So one thing I really wanted to talk about today is really about the practical solutions that we have been using, try to address some of those interference understanding, both from try to measure it and also just try to understand how it comes about. And before I go to this sort of 3 areas of solutions that we have, I really wanted to say that there is just one thing we have learned is you just cannot have a single solution that works for all. It really is, that's actually one of the reasons that we actually have several buckets of those solutions that depends on the situation and the problems that we solve that we try to draw. So the first one is what I would call a value of an action. So if you think about it on a social network, not every single action on the social network would have a cascading effect, right? So not all actions can spill over. So what we do is we identify those viral actions, and we only would actually be concerned about in experiment that there would be spillover effect if these viral actions are actually significantly impacted in an experiment. These viral actions can range from the obvious ones, such as message, invite, likes, right, to the ones that is actually a little bit interesting that we discover through some more extensive study, which is, for example, not every likes are the same. They don't have all the same cascading effects. If you are actually giving the very first like that somebody posted had, then obviously they actually has a much bigger impact on the people who are posting than the other subsequent likes, right? And then if you are posting something, obviously if nobody responded to your post, the social impact, the cascading impact in the network is also not as strong as if you have a post that has a lot of responses. So after we sort of identify these actions, then what we do is we try to apply IV technique, set of high signal experiments, try to study for the value of the action for the ecosystem. For example, we would be able to understand if I have one message, then what is the downstream value that it would be having for our sessions, right? Which is one of our true north metric that we use at LinkedIn. And similarly, we do the study for likes, invite likes to a post, et cetera, et cetera. And then when we try to understand the ecosystem impact from an experiment, what we do is we look at this Bernoulli randomization experiment, what is the sort of the first order session impact, and then we add on to it some of the downstream ecosystem impact that is estimated from those viral actions altogether. So obviously, it's a very, it's simple. You can apply it to all Bernoulli randomized experiments that we can do, run at very large scale. Obviously, it comes with a limitation because it doesn't consider the cannibalization, and also any rule of thumb does not apply, doesn't necessarily work for all scenarios. So we really have to keep that into consideration as well. But it works in general, give people sort of a sense of what the impact would be at a large scale. So the second bucket of approach is really on isolation, right? We talk about you can have interaction or connection, direct connection that can be introducing the spillover. You can have shared resources that can have introducing against interference as well. So you can think about it at a larger level. You can do geo-based isolation. You can say, I'm going to randomize on geo if you think that maybe in Uber's situation that the rider and the driver, they are isolated in a geo sense. And similarly, in the ads campaign budget competition example I shared earlier, you can think about I can take the ads budget and I can split it into 50-50, and then 50 goes to the treatment and 50 goes to the control. Similarly, I didn't talk about this before, but if you think about your training an algorithm and you have the data that you collect from both treatment and control goes into your training data. And so you could also just split the training data according to where that data is coming from as well to prevent that interference. So what I'm going to talk a little bit more in depth today is really sort of our journey of how we are thinking about isolation and then several of those approaches that we have taken in the past few years. So again, this is just a visual representation of thinking about you have a Bernoulli randomization, or you can actually cluster the nodes according to the connection that they have into what we call cluster-based randomization. So when we started, we actually designed the experiment. We took sort of a two-stage approach, right? So we take the graph, we cut it, we cluster it, and then we run experiments. We randomly assign treatment and control into different clusters. And then we also adjust for the network effect by building a model, essentially, based on what we consider as a network exposure model on top of it. So we did the experiment. We picked Netherlands because it was a very densely connected inward, but not as much to the outside of the world. And so we built 600 clusters, 300 in treatment, 300 in control, and we gave each of these clusters different feed ranking algorithms. And then, so what we found is, obviously, if I'm showing the results here, that the delta, obviously, when you consider network exposure, it's higher. However, they differ really a lot depending on which model you choose. And so this is some sort of like, the biggest limitation as if you think about very model-based approach as you are measuring network effects is that it's very model dependent. And then obviously the question practitioner always like to ask is, hey, so then which model should you use? Which one should I believe, right? So then we moved on to evaluating, just trying to say, hey, can we actually detect that there is a substantial amount of network effect in the experiments that we do by similarly approach, but we're gonna try run two type of experiments simultaneously, right? So we take the entire graph of LinkedIn, we cluster it, and then we split it into two experiment types, right? So we have Bernoulli randomization and cluster-based randomization at the same time. And then within each type of experiments, then we flip the coin. We give, on the Bernoulli case, we give every node a treatment. On the cluster-based case, we give every cluster a treatment. And we compare them. And then we certainly have identified a fairly strong network impact when we compare the delta of the deltas in some of the experiments we run. And again, there is a limitation. Number one is really the fact that we cannot get perfect isolation. As a matter of fact, the real graph is so densely connected that, obviously Martin here actually did a lot of these algorithms. We tried a lot of ways, and still we are only able to contain like 20% of the edges, so we are still cutting 80% of the edges that are actually between the clusters. So obviously whatever we are able to measure is still an underestimation of what the network effect really is. And then second limitation is really that it's a low power, right? So if you consider we have 600 million members on LinkedIn, and relative to like 1,000, 2,000 clusters that we can actually construct, so you have a much lower power when you're thinking about cluster-based randomization relative to a member-based randomization. And then, so then this is another approach that I think Guillaume already talked about. So we actually then moved into, instead of taking the graph and just like cut into different clusters and randomize cluster, we started to think about, hey, can we take a smarter approach as how we identify those clusters? So what we did is we say, hey, let's take some individuals in the graph that we consider them as spatial, right? So we're gonna construct the graph around them. So we have these egos who we're gonna be giving different assignments necessarily from people around them, those users who are connected to them. So this way we can construct a much, much better isolation than we would have based on an entirely cluster-based approach. And on top of it, we can also get a lot more clusters as well. So this is sort of approach that we actually have started to use very extensively in our production system. And then, so if you wanted to know more, you should have checked out Guillaume's talk or read his paper. Okay, great. So I'm gonna, so now quickly go through the third, how much time do I have? Okay, great. So I'm gonna just go through sort of the last bucket of the approach that we actually have been developing, and it turned out to be really, really fruitful for us as well. It's really thinking about it not just as a entity kind of analysis. For example, a lot of the way that we analyze experiments, are we saying, hey, like what is the impact from this user to this user to this user, but actually really focusing on sort of age-based analysis. And I'll say a little bit more about it. So now you can think about a lot of this leakage that we have on the sites. You can clearly isolate it or define it by these are interactions that is happening through certain ages, right? And in this example, for example, Jim here like sent a happy birthday message to Megan, and Megan replied and saying thanks. And then Jim says, you're welcome. So that simple interaction, again, thinking about if Jim is in the treatment and then Megan is in the control, that is where exactly that leakage is going to happen, right? So, and we can identify that in certain cases much clearly. So in this message send example, right? So if I'm just like picture it over here, that I have my control individuals who are sending messages not just to the other individuals who are in the control group, but also sending messages to people who are in the treatment group as well, right? So now if I can just like categorize those interactions, those edges, I can say there are 4 types, right? There are treatment messages to another individual who is in treatment, or the treatment messages to another individual who is in control, or control to control and control to treatment, right? So there are 4 different types. And we can actually, if we can analyze the messages on different those edges, we can actually able to identify the case where we can actually incorporate the network effects in addition to just sort of analyzing control and treatment without considering all this interaction that is happening in between. And so that is exactly what we were able to do. So we are able to estimate the true delta looking at sort of a control to control relative to treatment. I know it looks very simple here. It's actually, there's a lot of caveat and not caveat, but subtleties you have to take into consideration. For example, we can have experiments that have what we call treatment affinity, which is if you are, actually I can give this example. I think everybody has this feature already. So if you use LinkedIn, when you are on the messaging, you can actually see green dots in front of other individuals who are also online. So when we started running this experiment, what we noticed is that people are more likely to send messages to other people who are also in treatment. Right? So if you have treatment affinity, obviously this would break down, so you have to take into consideration all the other factors as well. So I think they're writing in their paper up, so when their paper is out, you can read it for more detail. But in addition to that, I wanted to say what's just really, really interesting as well is that we are also able to estimate what the response rate is different, right? So obviously, if you think about the network effect happens because I'm sending you an email or message and you respond back to me. But not every of those extra messages that your treatment is able to encourage people to send is encouraging the same amount of response, right? And for example, we have this what we call smart reply feature, which is like, you send a message on LinkedIn, and on the response side, the receiver side, they would actually get recommendation on what they can respond with, right? When we started that feature a couple years ago, we only give what we call quick reply, which is not a machine learned way, just like a very simple a few canned responses. And the response rate is much less than if we actually do a smart reply. So again, using their technique, we are actually able to estimate what the response rate differ across different experiments as well. And just high level, obviously, I have to remove the axis. It's actually really massive amount of network effects that we're able to see in our experiments. So in the first plot, I'm showing you the sort of the true delta or the ecosystem delta relative to simple delta. Then in certain cases, we are able to see over 100% of underestimation because of missing that network impacts. And there's like about 45 experiments that they studied, and on average, there are 50% underestimation in general, so pretty massive. And then the other one, which is also very interesting, if you're looking at the response rate, again, think about this. This is a response rate of those additional extra messages that your feature is able to encourage people to send. And it also varies quite a lot across different experiments as well. So again, I always like to talk about limitations as well. This works only on metrics that are attributed to an action. For example, it doesn't work on things such as session. It doesn't work on things such as if you wanted to estimate like users, unique senders, that it doesn't work. I'm out of time, and also I'm out of my talk, so thank you.
Stay up here, grab a seat, and Leslie, if you could join us. We're going to take questions from all of you now. But first, while you guys are formulating your thoughts, let me ask Leslie a question. Let me see. I think I have a few questions written down here. OK, well, actually, the first one when you started explaining about full disclosure, I mean, so one of the examples I thought was about some of our politicians who are or are not disclosing things like, so famously, Donald Trump chose not to disclose his tax returns. Yeah. So what you said it seemed intuitively, and it makes a lot of sense. I can see it in some contexts. It appears that he's made a decision that he's better off not doing that. As far as I can tell, that probably was the right political decision, isn't being punished that much for it. So can you say more about when this result you have is most likely to be true and when you think it may not be true, or do you think maybe he's making a mistake? Or? Yeah,
that's a great question, a multifaceted one. So one, kind of the normative question, there's a reason why people hide, right? Pleading the fifth, that's a prototypical example. Right, there by law, the jury's instructed not to make any inference. Right, which is also interesting. So we had these studies we ran that didn't make the paper, unfortunately, but where we asked people, we told them what pleading the fifth meant, and it was like sledgehammer. They had to read it and do checks to make sure they understood, like, it means that I can't infer guilt. My decision to make this person to have a guilty verdict cannot be based on information that they choose not to disclose. So we made it very clear. And then we gave them information on whether an accused person had pleaded the fifth or not, essentially whether they had answered questions or not. And then we asked the subjects, how likely would you be to recommend guilt? I mean, it's all a hypothetical survey, but even then people are still saying they will recommend guilt even when they're not supposed to. But it's this interesting duality, right? Like, you're not supposed to, but it's also not wrong in the sense that there is signal oftentimes to hiding. On the normative point, though, what I will say is that we have, I think I mentioned this, we have studies showing that there's a self-presentation error. That is, sometimes you are too scared of revealing information but you would make a better impression if you just came clean. So that was the example with, if you were answering an employer's survey to filling out an application and the real answer is not so glamorous, people think the best self-presentation strategy is to withhold, when in fact, on the other side, the employers are more likely to hire you if you reveal. So I think, like, when do we view people who withhold as really untrustworthy? I think when it's really salient that we have opted out of answering. And to come back to the Trump example, I think it's really interesting because, like, objectively, he's hit a lot of stuff, and recently that's come out more and more. But I think in many respects he has the perception of being a straight shooter and open, right? Whereas Clinton has the perception, rightly or wrongly, of being a hider, right? And there was one example where I saw kind of both working at the same in tandem, and it was before the election when Hillary, she fainted, and her approach to revealing information was reactive. So after she had fainted, she said, "Oh yeah, I wasn't feeling well." And then what did Trump do? He was proactive in his attempts to disclose. He said, "Hey, here's my health records." And so he was volunteering this information. Of course, it was just a selectively presented, cooked up, report. But so I think that these episodes like this kind of show how perceptions aren't always reality, and really the perception.
How do you reconcile that? I mean, can you say a little bit more about reconciling that with disclosing information?
Yeah.
So it's not just whether you disclose, it sounds like it's something else above and beyond whether you disclose that shapes these perceptions.
So the act of disclosure is really important. Like, regardless of kind of what the content is, the act of being open.
Or seeming to be open.
Yes.
So I think it's that old saying, like, sincerity is absolutely critical. If you can fake that, you've got it made.
Sigh.
But it does sound a little bit like that's what you're saying, that it's
the perception. I mean, what I also would, like, there are experiments on cost transparency, like, that is sincere. So the cost information we gave was sincere information. And so it's like a lot of what I study on what levers cause people to disclose or withhold information, a lot of them can be used to kind of trick people into sharing more, right? But they also can be used, and how I hope them to be used is to devise ways for kind of consumers and firms to work better together and to better realize the benefits of personal data without ripping consumers off. But there's that potential.
Okay, let me get Jan in, and then we'll take some questions. So, I mean, you present these three really interesting ways of dealing with a very, very important problem, and it's if you really think about it deeply, I mean, interference is pervasive. I mean, everything. All of us are interfering with each other all the time, as long as we're in the same light cone, right?
Yep.
So you do have to address it, but it does also, if you think of it that way, that means that even all of your solutions, you can never really be a solution. Like, if you do geographic isolation, in addition to the fact that, say, Netherlands is intrinsically different than Belgium, so you have that confounding issue, there's also the problem that there are always going to be some level of leakage. So can you say more, or maybe nuance it a bit, rather than solving or having no interference or dealing with interference? It's more a matter of degree, and if you think of it that way, does that lead to any different interpretations of the effects?
Definitely, and I think even in our journey as we are trying to solve this problem at LinkedIn, I guess we just come to the conclusion. I think early days it was more like, hey, there could be interference, and then that's why we kind of did some of the experiments in the early days, and then until the point that in the last sort of the age level analysis, we were like, these are huge in impact. So I think that is sort of one learning that we had, is like, hey, the magnitude actually can be huge. But going back to your question of like, hey, there is always a varying degree, definitely, and that's why we the way that we think about it is going back to our first approach, the value of action is. When we see, we always know that there is going to be some interference as people are connected, and then if you liked something, that is more likely that your friends will like it as well. But in order to actually see whether that has any tangible, significant sort of implications for LinkedIn as a company, that we will have to sort of start with, hey, does this even have a first order impact?
But
in that
but your baseline, the quote no interference case also has interference, right?
Certainly, just like
And you don't know how much there is really.
the ones that I want to say the ones that we say that there is no interference, we are pretty confident that there is like the interference is not big enough for us to care. For example, if you have an experiment that is not even either changing how many viral actions that people do, first order, or if it doesn't change how they are responding to others, or the mix shifts between different type of interactions that people have, then it's very unlikely that you're going to have an interference.
Unlikely.
Unlikely,
I
yeah.
mean, if I'm sympathetic, I agree with you. But if I want to be very, skeptical, then I mean, they may talk to each other on the telephone, or they may do other things that you don't observe, right?
That's true. That's true. And I would then, from practitioner standpoint, I would argue those are probably small enough that we don't really care, right? In the measurement case. So the ones that we are able to observe, and then in the first order case, then that's when we actually wanted to care more about the second case. And I also wanted to say that there is very, very few features on experiments that we run that has, like, let's say, a very small first order impact, but really has a huge cascade second order. That is extremely rare. And what we have observed is almost like, if you have a very strong first order impact, then you're going to have a second order impact, but not the other way around.
Okay. Well, I'll come back to you on some of those things, but let's get some other people involved here. I think there's a question right here.
Question for Ya. So I was wondering, it was very interesting to see the figure of one experiment every 5 minutes at LinkedIn. And I was wondering if there are any bottlenecks or constraints on the good ideas that you have that you can actually test via the experiments. And if so, where do these ideas come from? And what do you see as a big constraint for coming up with the ideas that you actually test?
We are, again, we don't have, like, obviously we have a centralized experimentation team that's focused on building the platform and enable everybody in the company to run experiments. But we have 4,000 engineers. If everybody have one idea a day, we have 4,000 experiments every day. So we are far from being bottlenecked by the number of ideas that we have. I do wanted to say that I think by and large, we definitely have categories of experiments that is like, hey, this is a really big idea. Let's go test it out and then figure out how it works or not. And then we also have ideas that failed before, and then we think about ways to tweak it, think about ways to sort of iterate on it, and that'll be sort of the next version of the experiments.
Great. How about over here?
These questions for Leslie. If a company decides that they want to disclose, say, pricing or something else for, say, 5 products, then they build some level of authenticity, and then they say, okay, now we're not going to disclose. Yeah. What's the impact? Do they lose the trustworthiness, or the fact that they've done something?
They disclose for 5, but not 5 others?
Yeah, so they say the first 3 months they disclose for the 5 products. They introduce a 6th product with maybe perhaps very high margins, and they say, oh, we're not going to disclose for this.
Yeah, I love that question. So we've done some studies that look at kind of what you're saying, but at a higher level, like firms. So if a firm is disclosing the costs and you know that another firm is or is not, so that moderates the effectiveness. So intuitively, the benefit is greatest when the other firm, when you know that the competitor is not disclosing its costs, because then it feels like the other firm really is hiding its costs. But within firm, that's an interesting question about what might happen if some of the products have the transparent pricing and then other ones don't. In our first study, that's in fact what happened. Some of the wallets had the cost transparency on it and others did not. Which kind of, what you're saying, it's a little bit ambiguous as to what is driving the effect in some sense, right? There could be some people are kind of annoyed for the wallet color, if they're surfing between colors. But we also find that when we restrict the analysis to people who don't look at alternative colors, so they only see the one treatment, the effect still holds. But I think it's a really like kind of joint versus comparative evaluations, joint versus separate evaluations, whether we're comparing a company that discloses versus doesn't, I think can really moderate these effects.
Another question right there.
Follow up for Leslie. So we understand that basically people do not care about Fifth Amendment, and they, maybe they don't understand what it means. But what about non-disclosure agreements? What do you think that? Do you think that people understand that if I tell you I can't tell you because I can't, I have a contract that I can't, then they discount the lack of disclosure or not?
That is a fascinating question. My intuition would be that if you say you have a non-disclosure, like you just get the penalty. People don't take it. I'm stating it as if it's a fact. It's not. It's just me riffing. But my intuition would be that people wouldn't correct for the situational influence on your behavior. The situational influence there being this contract that you have, and I think you might suffer that judgment penalty. That would be my intuition. I don't know. Is that your intuition? Yeah. Yeah, of course.
Well, yeah, I'm not sure I had that intuition. I mean, one of the things that bring back Donald Trump, he said, I can't disclose because I'm under audit. So I'd like to, but it's out of my control, and that seemed to buy him a little bit. And so, I mean, objectively speaking, if there's something beyond your control that prevents you from disclosing, you shouldn't infer something about what they're disclosing.
Well, objectively, but again, like kind of what I see again and again is like objective reality is often not how, like the psychology of how we interpret people's behavior.
Like
but it's an empirical question.
Yeah, exactly.
You should study it.
Great. How about someone on this side? Is there someone, how about right here, right in front?
Hi, this question is for Leslie. So regarding self-disclosure, on an interpersonal level, like, is there any effect with not disclosing, or self-disclosure on an interpersonal level, is the effect disclosing to the person that's one degree, I guess, separated from you versus others that person discloses to later? So, in other words, yeah, if you're disclosing something to, say, a loved one, and then they say, oh, like, I asked them this question and they didn't answer, or I did ask them this question, like.
Or like the auditors, like companies get audited, and then the company the auditor is supposed to say, okay, we've reviewed this and we found no fraud or whatever. We don't comment on the fraud.
Does the positive impact of self-disclosure, does it remain equal as you move out the social network?
Interesting. So there's again, multifaceted question there. One question is whether, like, if you think back to what I was saying about the kind of temporary sharing stuff and how it can make for enduring bad impressions because it causes you to share more risque content. One question I have there is, like, imagine if it's kind of like a principal agent, like if someone else posts a photo of you, you had no say in that. Who's viewed to have bad judgment, the person that posted it or the person in the photo? I would guess, this is just a guess, that it's the person in the photo. And on a bigger level, I think these questions of other people sharing our information are fascinating and scary and important, like the DNA, right? So people who upload their DNA, send their DNAs into Ancestry.com, and because they're curious to find out, like, their ancestors, and then now law enforcement is piecing together crimes. Like, there's a good and a bad to that, right? The other thing that it brings to mind is some work that we've done on bearers of bad news. So what we find is that people shoot the messenger, figuratively, where when someone has to break bad news to you, and it's not at all their fault, they had absolutely no role in the generation of the bad news, the recipients nonetheless view those bearers of bad news as untrustworthy, as unlikable. And so one example of how we show this effect, this is like a rarefied lab experiment, where what we do, because we want to kind of show the effect very tightly, and by tightly I mean we want it to be very transparent that the messenger, it's not their fault. So it's like an error, right, in judging the messenger as unlikable. And what we do is we have participants in our lab write down a number, and then we have 2 research assistants up front. And one of the research assistants draws a number from the hat, and if the number drawn is even, and you wrote down as a subject, you wrote down an even number, you get a $2 bonus. If it's odd, you wrote down odd, you get a $2 bonus. If they don't match, you don't get that bonus. So that's kind of our manipulation of good news versus bad news. So the number is drawn, handed to another research assistant. So not only is the news it's random, transparently random. The messenger isn't even the person that draws the number. So the person that draws the number hands it to the messenger. And I instructed my RAs to be mimes in this, so it's very clear. They're drawing the number, they're handing it to the other messenger, to the other RA. The other RA is just a messenger, opens it up and says, I have good or bad news for you, depending on what number was drawn. And then we get the subjects to rate the messenger, how likable, how trustworthy, and they find that messenger, the innocent messenger, is untrustworthy. And then we go on to show it in scenario studies with physicians, right? You can imagine all the applications where if the physician tells you you have some terrible ailment, patients, these are scenario studies. I would love to do a field study, not just necessarily showing the effect, but showing interventions. That's kind of my next step. But
well, remarkable. Speaking of field studies, when people recommend people on LinkedIn, and you have all sorts of second order or potential interference, do you have any experiments or data that might shed light on that in a
one thing that came to my mind is in our feed, as you are going to our feed and you see sometimes you see somebody posted something, or some says, hey, so and so liked it, and that is why you are seeing this. One thing that we definitely notice is that if you have what we call social decoration,
what's a social decoration?
It's not just give you the post, but also tells you that so and so in your network actually liked it. That's what we
social,
call
I see.
the
So
social
it's
network,
to,
social decoration aspects of it. That definitely increases your engagement on that post itself, even if it were just the same post. So certainly, not in the way of messenger shooting the messenger, but it's the other way where you.
Have you done any experiments that you're aware of where you've tried to do this sort of experimental manipulation of generating good news or bad news that then gets shared?
Good news and bad news. We don't do good news and bad news. No, we don't do that.
One field study that I've been trying to get run is it's working with a bank where they send people letters sometimes telling them that their credit limit has been decreased. So we're talking about how to play around with the way the message is framed to hopefully reduce complaints, say. Might be a way we could do it in the field.
All right, we've got a lot of hands. Let's get some other quick questions in. How about right over here? And then we'll go to Dave, and then we'll continue on over. Go ahead, right up this front table here.
So related to interference, a lot of times at least on our platform, when we run an experiment, we might do it on 1% or 10% of users, and then we hope to roll it out to 100% of users. If the structure of the graph or the interference is perhaps dominating the treatment effect, what are you seeing when the structure of the graph may be different on the experimental portion of the graph versus the expanded portion of the graph or some other subset of the graph? When you roll out from, say, 10% to 100%, how do you see that interplay, or how do you measure that difference?
That's a great question. So I want to say 2 things. One is if you are just running an experiment based on Bernoulli randomization, then obviously your 1% or your 10% is a very representative sample. That is, again, even in the network structure, is a representative sample of the whole graph. Right? But in that case, however, what we have noticed is that depends on the RAM percentage or the treatment percentage, what you measure can vary. For example, I gave the example of where you have a green dot on people who are in your network who is actually active on LinkedIn. That experiment, what we have noticed is that as you're ramping up, because to some extent you have almost like a dosage effect, right? You are increasing the dosage of people using that feature on LinkedIn. You actually will increasingly see a bigger treatment effect as you're ramping up.
Well, bigger total treatment effect, but maybe but the marginal effect might not be increasing.
Both, actually. Yeah. So in that case, it's both. But you are right. So it could be the total. So we and then so that's one example. Another example would be, let's say I wanted to recommend. So in our connection recommendation, I can say, hey, let me actually go ahead and recommend more students, because students are the ones who are really needing connections in our network. And so if I actually started to show everybody more students' recommendation in their connections, and then I only do it for 50% of the students, like the effect that I'm going to be able to measure is going to be very different if I have all 100% of the students are going to be recommended.
Right, but I want the marginal, I mean, so if I'm already getting messages from 9 of my friends, adding a 10th friend may not have the same marginal impact as if it's the
exactly.
first person.
So you can see that it's interplay, right? On one hand, there is a dosage effect as you are. On the other hand, it's like as the starting to be competition, not diminishing return.
Yeah,
to that extent.
usually.
So yeah, so you kind of have both of these effects even in your Bernoulli randomized experiments. So now it goes back to the other side of the question. So what if you actually do some sort of a smarter way of cluster your graph, and either in our cluster-based randomization or in our EgoNet randomization? One thing that we do very carefully is when we construct that, we have to make sure that it's very representative. So we do sort of out of sample, we do make
clusters are representative.
The clusters are representative.
Because almost by definition, there's some reason people are clustering. It may be outside of your model, but you know, they're not randomly assigned to clusters. They have some kind of affinity for each other. So presumably, there's some unobserved variable that's driving that may also therefore affect your effects.
Absolutely. So in the, for example, in the EgoNet, what we do is we make sure that the egos are sampled randomly, right? And then as we are constructing the graph, one thing we have noticed is that if you are an outer, then you are more likely, if you have more connections, obviously you are more likely to be an outer. Right. As well. So a lot of these things that we have to make sure that it's actually representative as we're doing this.
This is a question for Ya. I guess I was just wondering, within LinkedIn, or I guess any company, to people in this room, like spillovers are a big concern. I guess I'm wondering, does it take a lot of convincing to get people to buy into these more complicated experiment designs? Like, are people generally worried about network effects? And I guess, you know, if you do get some network effect result that maybe goes in the opposite direction that people might expect based on their priors about how the network effect should go, are people, you know, do you sense that they're maybe more skeptical to actually believe the results because they come from a design or, you know, an analysis technique that's maybe a bit more unfamiliar to them if they're not a statistician?
That's a great question. So fortunately, we don't have that problem at LinkedIn. So I want to say that even when, like a few years back, before we were able to develop some techniques to measure it, there is always that desire of, you know, we wanted to understand viral, we wanted to understand how people are engaging on the network. And I want to say it started a couple years ago. There is even a stronger push for being able to understand that network effects than ever before, because of sort of we are really starting to push for sort of our community strategy, what we call active community strategy, where we wanted to get people to talk more with each other. We wanted to really sort of have people who are on the platform, using the platform every day to sort of really draw in other individuals who are not necessarily as active. So I think there's no sort of the challenge from that perspective, but more sort of like, hey, we wanted to be able to do that. Can we have the right technique to do it? On the other hand, the question of, hey, what if, you know, the effect comes out to be against people's intuition? I actually, in most I'm not able to think about one that is actually against it. I think it's maybe there are cases where people think that there is a strong network effect and turn out there's no. But I've not seen that people think about it as a positive network effect, but it turned out to be a negative network effect. I have not. Maybe some people in my group can think of any, but.
Wait, and also it could be heterogeneous, and then that gets even more complicated.
Oh yeah, we certainly, I mean, heterogeneity is a
positive for some, negative for others, and then
that's for sure. That's for sure. And actually, we do care about that in particular, because again, I think about LinkedIn is mostly based in US, and then we are. Most of our traffic is actually coming from international nowadays, and like we actually really, when we run experiments now, we really wanted to actually understand, is it doing good for people in China? Is it doing good for people in Japan? Like, so when we see a lot of experiments that we launched historically, ended up actually having either negative or flat impacts in some of those countries.
All right, time for one or two more quick questions. So maybe right there, you had your hand up for a while, and then we'll go way over there because I hardly see those people over there. Still connected though.
Hey, a very quick question for you. So you talked about the very constant difference between the first and the second order benefits of an action, right? So anything specifically there that surprised you? Like in the timing effects of advertising, we always say the long term is about twice the short term effects of advertising impact. Do you see something similar as a ratio between your first order and your second order effect?
Oh, I don't know the ratio between short-term and long-term in ads. And as a matter of fact, I know it's actually depends on who you ask and what study you refer to. Even that the ratio can be different quite a lot. But in our case, first order and second order, and also varies quite a lot, depends on the feature. You can have a feature that is very much increasing people liking posts, but they don't necessarily have a cascading effect, and vice versa. We actually would literally come up with algorithms that may not be necessarily impacting much of the sort of the first order, but is actually try to encourage things that is having a further down the road.
You can calibrate that, then you can know how confident you are that these things aren't interfering. If it drops off very quickly, then you may know that, okay, things that are third or fourth probably aren't going to have any meaningful effect. But if it's more constant, you may have to worry.
Yeah, absolutely.
All right, one more quick question over there in the corner.
We've heard a lot today so far about the impact of confounders and mediators. I'm wondering, by clustering units to be very, very similar units together and then randomly allocating those clusters to treatment and non-treatment, would that potentially make worse the impact of confounders, which might influence small numbers of it? For example, you've clustered a bunch of people that maybe are closely linked, but if your treatment affects them extremely differently than it affects the rest of the population, they're now less likely to be represented in both base and variant.
Yeah.
I'm wondering if you can comment on that.
A great question. Actually, no. The reason is because you started to now treat each of those clusters as your random samples now, right? So you are randomizing based on that cluster, and imagine that you actually have tons of clusters. Then essentially you are using randomization to control for all these variables that may not be foreseen. But
in a way, it might help actually, because whatever unobserved might be correlated with those clusters.
Right. But do keep in mind, however, is that if we are doing this cluster-based randomization, you don't have that many clusters. And then if you ended up having, let's say, a gigantic cluster that happens to be in treatment, then you are in bad luck, right? So what we do is again, we actually say that clearly in our paper, is like we actually try to balance the size of the clusters, right? So that turned out to be actually a very good way. And we also do stratification. We also try to in a way to marginalize those as well.
There's two kind of offsetting effects there. One is you have fewer data points to work with, which obviously isn't a good thing. But the other thing is that there may be some unobserved things that you are now, if you have fixed effects or something, you can help control for.
Yeah.
Well, we are out of time, I'm afraid, but let's thank our panelists and our speakers.